Assalamualaikum warahmatullahi wabarakatuh. I am Kamil Zaharuddin. Alright, today I will going to present about the programming project on how to implement fluid mechanic formula. And my matric number is AD150193 and I'm from section 3. And my lecturer is Dr. Zaini bin Yunus. Alright, this is my introduction. As we know that the fluid mechanic is a branch of fluid study of engineering. It divided by two branch. Firstly, static fluid and then the dynamic fluid. Okay, it can be investigated by using computational method, by using the dynamic fluid theory, and then the flow can be programmed by using for loop where we have the range, and then by using the desired formula. Alright, this is the velocity profile that I'm going to investigate on how the flow of the fluid in the pipe and the velocity profile, the velocity, and then the characteristic of the flow. Firstly, you know that the fluid in pipe consists of two. Firstly, the laminar form and then the turbulent form. Okay, this is the problem statement. As an engineer, you are required to design a device such as sensor to detect the type of flow in pipe with the range of velocity and its changing. Hence, the final velocity frictional force is determined as the pipe is multi-purpose. Different substance is used such as petroleum and water is being tested. In this problem, I have to use the petroleum and water, which is different density. And then I would like to investigate on how the flow and then or the frictional loss at last of the pipe. Right, this is my formula that I will going to use. Firstly, the Reynolds number formula, rho Vd over mu, where the rho is the density, V is the velocity, D is the diameter, and mu is the kinematic viscosity. And I will going to use the V velocity when it reach 1 meter per second. And then this is the formula of major loss, the frictional factor, the F. When the flow is laminar, I will use 64 over the Reynolds number. And then the turbulent, I will going to use 0.316 over Reynolds number, power of 1 over 4, which means I assume it is a smooth pipe. This is my problem statement table. Firstly, the P, where is the fluid density value. We use petroleum density and water density, and then this is the range of my velocity 1, 2, 3, 4 to 6, and then the D, the diameter 3.0. I just fixed, but we can change the diameter what we desired, and then the K, kinematic viscosity, which is 2 to 3 and 4 to 5. Then this is my objective of this project: to determine the density of the substance, calculate the Reynolds number in different velocity and viscosity range, determine the type of flow in the pipe, and calculate the frictional factor in pipe to determine the loss. This is my flow chart. Alright, as we see that we start with we put the integer and then the Reynolds number for the desired one 2100, and then the diameter 3, and then the rho kV, where the density, kinematic viscosity, the V, and then the max Reynolds number. And then we could see that the desired density we put here. Then when velocity is 1, right, if true, we go to there, and then the loop, if we force the velocity, and then we back to the first loop. And then if it false, it go to the V equal to 4. And then when it true, we take the kinematic viscosity. And then when it false, the flow is going to the formula of the laminar loss, which is 64 over max Reynolds number. And then after we do that, if it's not, we go into 0.316 over power of 0.25, which is the value of frictional factor, and then end of process. If it's true, it go into the kinematic viscosity, and then for the loop, if false, the velocity will back to the first statement. And then if false and turbulent form, back to the B function, and then to the kinematic viscosity, and then back to the first loop. We going to investigate again and again until the loop is satisfied, and then it will go to the end. Alright, this is my program. Okay, this is my program, and then I will going to wait and run. Firstly, for the petroleum, we know that the density value is 550. And then our desired diameter is 3. Alright, this is the value of frictional factor, the Reynolds number, and then the type of flow, which is the laminar flow. Okay, we see it have 12, which means my range is 12. And then we know that for the last flow is the laminar flow, which means that the petroleum is a laminar flow at last. And then I would like to run again for water. The density value is 1000. Then the diameter we fix at 3. And then we could see that it is turbulent form until at the last we get the turbulent form. And then the value of frictional factor is 0.040765. My conclusion, the flow impact can be determined by using the Reynolds number, and it is important to determine the Reynolds number because from the equation frictional factor can be determined. From the result, it could be concluded that the frictional factor is decreasing as it flows from as velocity and kinematic viscosity increase. Then the viscosity range is inconsistent type of flow. As it travel velocity, it affects the result. And lastly, from the frictional factor equation, the energy lost by the fluid can be calculated. That's all from me. Thank you for Dr. Zaini.